Hello, everyone, and welcome to this webinar. So, uh, thank you for joining. I will start with the agenda because it will be quite a busy webinar with different topics and introduce a person today. So I will start with the introduction on my side to talk about scalable cloud, the topics, the challenges, and then introduce my co-speakers. We will have a first part by Alexandru about modernization for scaling, and where he will share his feedbacks and what his company achieved. Then we will have a moment with one of my colleagues, Robin, which will talk about Bond with the expertise of what they built with OVHcloud. And then for the next part, we are going to have Alexander from EMD to talk about how the next generation CPU can help us globally in the IT and help faster innovation. And of course, at the end, we will take some time to have question and answer all together. So if during the webinar you have questions, feel free to ask them in the question box you have in the interface. So like that, if there are quick and direct questions, we can answer them in the chat. I have a few colleagues here to assist. And if you have questions you want to ask to our panelists today, feel free to ask them in the chat and specify the people you want to ask the question, and we will address them at the end of the webinar, so we can keep with the flow and have our introduction and different topics going on and address the questions at the end. So again, thank you for joining, and I will start by the introduction. So let me introduce myself. I am Remy van de Pol. I work as tech evangelist at OVHcloud since more than 15 years now, and I will be your host for today. So I thought it was important as an introduction chapter for the webinar to align ourselves on some definitions, because I think it's always a good starting point, and especially about scalability. In the industry, usually it's the ability to handle all offload and try to manage the complexity at the same time. So usually as architects, we have to look past the auto-scaling features, because there is no magic. Okay, we have some helps, some amazing tools, but there is no magic. So we have to find the best way and the best tools, the best infrastructures to build our applications on top and really have something powerful. So we have to ask ourselves, of course, technical questions, for example, about the storage, the compute, the network, and then translate them into infrastructural answers and solutions. How can we build an infrastructure answering these questions? And usually we have to look at the schematics I put on the slide, that when we want to scale, we have different options. We have the growth, which is quite linear. We have more people visiting our website, using our application, using our tool, and most of the time it's translating into a complexity and a cost going up. So it's quite linear. If we don't do anything smart, it will stay as is and cost money when we want to have more people on the app or on the website. But by thinking a little bit differently, with more tools and the feedback we can have today about what's going on the cloud, we can try to build something a little bit smarter and try to not grow, but scale. So it means trying to be smarter and not wasting resources to have a smaller shape and do some savings in the middle. So to make that little story short, scaling is about keeping a constant quality of service. That's what's important when we have an application live. And of course, it would translate into technical specification. And about technical specification, we have quite a dilemma when we try to scale. Here it's more like a trilemma because we have to find the sweet spot between performance, security, and flexibility. Of course, we want to have them all, but we have sometimes to make concessions, and it depends the chronology. I've been in the field as a sysop or architect a couple of years ago, and the main KPI was delivering fast. Now it's not the only preoccupation on the IT side. We have to deploy fast, but to make something maintainable, something flexible and safe. So it's a little bit more complicated now, and we have to play with these three pillars. We can't optimize one and ignore the others. So they really are important pillars, and we're going to address them today because we think it's an important view to have when you are building or modernizing your application, and keep them in mind. And that's what we are going to talk about. Our first two guests are going to deep dive into this, how to keep these three pillars in equilibrium without one collapsing on the others. And to start by addressing these topics, let me introduce Alexandru from Bitdefender. I will let you introduce yourself and the topic you are going to put in light today.
Thank you, Remy. I hope everyone can hear me. I'm Alex Novak. I'm the Director of Cloud Services and Infrastructure Unit at Bitdefender. I really liked what Remy said about there is no magical solution. I want to echo that sentiment. What we have is knowledge and using the tools that we have to the best of our abilities. I have been with Bitdefender for 16 years now, been director of cloud services probably ever since then, but it wasn't a position then, so I was just doing the job. The position became official, I think, about 10 years ago or something like that. I'm also in charge of some parts related to big data management, our internal telemetry solution, as well as our online threats solution. So a lot of things going on there. But for today, my main role is that related to cloud services and infrastructure and how Bitdefender decided to handle this situation across the organization and across the multiple teams. Yeah, so that's mainly about me. Now let's talk a little bit about what we are doing here, and then we'll talk about how we are doing it. So I'm going to start with a brief history just to give some context around what our needs are related to our cloud solution. So this project started somewhere in around 2009 and materialized somewhere around 2010. And we didn't think back then how big it's going to be, but we knew that we needed to move some of our logic to the server side for various reasons. One of them being the ability to update faster than through regular updates of the application, and to give better detection to our users that way, or faster detection. But what we needed was a platform that would deploy globally as we had users globally. And also, the internal structure of the company means that we have developers in various teams that have or had, at least at the time, different internal procedures and ways of doing software deployment. Also, the schedules were very different between the anti-malware and the anti-spam teams and all the other teams, they all had their own schedule. So we needed a platform that would allow them to keep doing what they were doing with minimal impact to their daily work, but also be able to deploy reliably over a global infrastructure that would serve the users. Initially, we had around 10 to 50 unique services. So in 2010, we started with around 7 or something, then grew to around 50 uh, in 2014. And they were running between 100 and 1,000 instances, again, growing, scaling, just like Remy said, over that period of time, as our users were increasing, the user number was increasing, and our internal needs increased. Because once you do something and you realize, okay, I can do more, but that's more compute power, so we need more instances, we need more CPUs to run that. Also, at the time, we grew from 3 global distributed points of presence to 5, and we felt that okay, we have a good coverage back then. And in order to accomplish all of this, we developed a management platform that our internal users were using. But this had a lot of limitations. For instance, we were only able to deploy I believe Node.js and Python services, and that's it. And they had to be in a specific, built in a specific way in order to be deployed over our platform. It was obvious by 2014 that we had reached the limitations of the platform. It was increasingly harder to manage it. We had to say no to a lot of people when they requested various functionality because it wasn't possible on the platform that we had. And also, we had a lot of problem with the resource cannibalization between services, since they were all running on the same servers, distributed, but sharing a lot of resources. So we started looking at Docker as a way to help us manage this infrastructure, and we started doing some tests, and we started to see there are a lot of benefits there. Did we decide to go with Docker? Well, not really, as we will see. If we move forward to the next slide, what we actually did was, after we did a lot of research and tested a lot of orchestration infrastructures for Docker, we decided to work with Kubernetes. I think the first deployment of Kubernetes that we did was Kubernetes 1.4, maybe, something like that, which for those who know, it's a whole different story than the current version of Kubernetes. A lot of things were baked in, a lot of things were inflexible back then, but still it allowed us enough flexibility to improve our platform from what it was before to something more flexible for our users and easier to manage on our side, with additional benefits like resource segregation and a better security model. At this point in time, by 2016, we reached around 6 points of presence around the world. We had more than 200 unique services in 3,000 instances. Initially, these services were used by what we call our internal laboratories team. So the teams that were handling detection and security services for our applications. But a lot of our other departments, such as our product and application team, realized they had a lot of functionality that could benefit from cloud services. So they started developing services for those applications as well. I was actually part of the initial development of those services, and then they were taken over by the responsible product teams, and they carried them over ever since. But that's how the number of services grew, the number of instances required grew as well. And we rebuild the whole management stack and the whole application that our internal users are using through Kubernetes. This allowed us to deploy the same managed infrastructure across various cloud providers. Initially, I think we weren't even using a hyperscaler when we first used Kubernetes, or at least we were using AWS and other data centers before moving initially completely on AWS. And what we were trying to achieve all the time is a little bit of infrastructure independence that Kubernetes really allowed us to do, as well as easier management and better control over what was running. As I mentioned before, resource cannibalization between services can be a real issue, especially when there's multiple teams working on them. And now let's move on to how our current infrastructure looks like. So we have over 5,000 services, 12 points of presence around the world, around 37K instances of those services running on this infrastructure. We are handling between 500 and 900,000 requests per second on this infrastructure at this point, running on a lot of vCPUs. And we are still running on Kubernetes. Everything works fine. Kubernetes scales. Luckily for us, it developed alongside our needs. The most obvious one that I will come back later on for another point is that initially we wanted to run everything on Kubernetes, including databases. And for the initial versions, like I believe until 1.10 or something, even further than that, everything you read on the internet was do not run your databases on Kubernetes. Kubernetes is stateless only, do not run them. Well, we ran them because we would like to push the limits of everything that we are using, and we really saw the potential here and saw this as a problem that needs to be solved, not as a restriction that we need to obey. So yeah, Kubernetes has been grown great for us. We have rebuilt our internal management team to accommodate again our users' needs that are growing alongside with the industry and everything else. And we are right now in the process of rebuilding it for to incorporate even more flexibility and even more requirements and make it even easier to use based on the new requirements that appeared from our internal users. Now, when I'm saying rebuilding the management interface, this doesn't just mean the management interface that handles and configures Kubernetes. It usually means how we are driving the processes and configuring everything in order to achieve the goals that we have. And the management platform is more like a presentation of those ideas and philosophies towards our internal users. So this is kind of the history and how we are looking and what the project looks like. Now, if we move forward, let's get to how we went about choosing OVHcloud as our partner and the infrastructure. So we needed to broaden our services, and we wanted an European partner. We were running on GCP at this point. We moved from AWS to GCP. We are still running on GCP, but we wanted to extend our services, and we have a lot of more flexibility in where we are running and not be related to only one hyperscaler or one provider. And we needed a partner with strong network and multiple points of presence throughout Europe. Now, during our lifetime, the lifetime of our project, we have come across a lot of limitations from a lot of service providers, including big ones. So we kind of know what we are looking for when we look for a partner. So I'm distilling things down here, but strong network is a very important one, and not every provider out there is actually able to, in reality, deliver that. What we also found was that OVHcloud had a managed service for Kubernetes. This is not really a requirement for us, as we have our solution deployable on any infrastructure, but having one less thing to worry about and having one less thing that is handled by the provider is always a plus in the workload required to deploy and maintain infrastructure. So that's, while not a requirement, a great thing to have. Wanted to have someone that we could build a partnership over time, not a one shot or something like that. And during our search, we found that OVHcloud was a strong fit for this, ticked a lot of boxes, and we were happy to start working with them and see how things go. So I want to talk a little bit about our experience with OVHcloud and share how everything worked so far, what went great, what maybe didn't go so great, what are some strong points that we've seen, and so on. So first of all, related to the Kubernetes support, this is like a short agenda of what is coming. So Kubernetes support, some issues that we have encountered, a little discussion about the transparency of the pricing structure, the user experience that we've seen, and of course, one of the important things is that we were looking a partner that allows us to have EU data sovereignty, not just in data centers, but in the company behind it, and running it as this is very important for us as well as for a lot of our partners right now. Okay, going over the Kubernetes support, what we have found, starting with at the start of our deployment, if you can go to the next slide, please, is that first of all, we knew that they offer a managed Kubernetes service, but we didn't know is how simple it was to configure, which is always a breath of fresh air. The process for controlling, for setting up the control plane and node pool, again, very simple and straightforward. And it also allows us to customize the worker nodes, the compute nodes, to our specification and our requirements related to resources and software configuration. We will go into that a little bit further later on, but the most important is that we were able to achieve everything that we needed for our setup very easily. Another very important thing related to Kubernetes support in OVHcloud is the regular updates to the latest version. Very important, again, we can do that on our own, but the fact that the platform supports it is a huge relief always, because it minimizes the work that we need to do. And over time, this adds up to a lot of months of work. So always happy to see that. And one very important thing related to how OVHcloud implements Kubernetes and region and multiple availability zones within a region is that there are no network traffic costs within the same region. Why is that important? That is important because it allows us to create Kubernetes high availability clusters that actually work within a region. Most cloud providers do not support this, which means that you either have to do very complicated configurations in order to get this working without huge costs, or choose a different strategy for your high availability solution. This point right here allows everyone to add a very simple high availability solution to their infrastructure with no costs and barely any configuration. So a huge plus in our mind and our eyes for this setup. Okay, let's move to the next one. We did have some issues deploying to OVH. Some were from how we used to do things maybe, and our limitations, our requirements, and we will go through a few things that are maybe more relevant. As I was saying earlier, we run everything on Kubernetes, including our databases. Our database engine, probably a lot of other database engines as well, require some very specific operating system configurations, such as a high file handle limit. And the initial configurations of the worker nodes had a very low limit on this, so it means that our databases couldn't really start on the infrastructure. But we talked to the professional services team from OVH, and we found a workaround which we implemented in order to solve this problem, which is great. I mean, it's always great if you find a solution, but we don't really love workarounds, because workarounds is something that you have to keep in mind for all the future of running on that infrastructure, and never forget it, or you will have a problem with your infrastructure when you do an update 2 years later and you forgot about that. So we were extremely happy to see that within 2 days, the core problem was solved by the engineering team at OVH. So we no longer needed to use the temporary solution. And I think, excuse me, this is the kind of thing that you're expecting from an infrastructure partner: the ability to talk to them, to find solutions, to find workarounds, but those workarounds need to be um, separated in time, like by a complete solution from the platform, so we don't add to the complexity of the solution over time. Another thing is that the documentation for the platform didn't quite cover everything. Now, this is something that is important or not, depending on everyone's style of work. Now, to be fair, OVHcloud uses a solution that has some public documentation, but we didn't previously use the solution, so we weren't really familiar with it. And we kind of expected the documentation to be within the documentation of the cloud. But why did we expect that? Because we eventually reached out to the support team and got a lot of help from them, so they were great and solved all our problems. The thing is that this, as I was saying, depends on how everyone is working. We like to be very self-reliable and not go to support teams unless there is actually a problem, and we did everything on our part to try to fix that problem or find what is going on and then go to the support team. A lot of other teams, even within Bitdefender, prefer to have direct communication with the support team and just handle everything like that instead of going through the documentation themselves or other means. As I was saying, this is somewhere in between, since there was documentation, we just didn't know about it because it was a public type of documentation for a software we weren't familiar with. But in the end, we find solutions, and everything was great from that perspective. The support team was very helpful and helped and pointed us to where we needed to look. Also, this is more of a personal thing maybe, but I think that some dashboards could be improved within the console for managing the Kubernetes clusters and the infrastructure. We talked with the engineering teams, and we will see how they prioritize, or if they prioritize those things, depending on other users' needs, of course, and their internal schedule, but nothing too big there. Just some nitpicky things. We really like a good, optimized, and efficient dashboard, as we will see later on. Okay. Let's move to the next slide, please. The cost transparency. Oh, you went there here already. I talked about earlier today a little bit about cost transparency. Now, the way they are presented within the OVHcloud infrastructure is actually easy to understand and predict. This is not something common within the cloud industry. If you have ever had to predict costs within AWS or GCP or Azure, you know what I'm talking about. Our latest experiences with GCP were that we needed a master's degree to understand how the costs are calculated and what the prices actually are in the end. So the fact that with OVHcloud this is very easy to understand, predictable, it's a huge, huge plus. I mentioned earlier about the free unlimited traffic between services in the same region. A region has multiple availability zones, multiple data centers. That means that if one availability zone goes down and the others are still alive, your service can be up and running if you deploy your Kubernetes cluster across a region, across availability zone. And the fact that there isn't any cost to the traffic between these availability zones is a huge plus, as it makes the decision to deploy in this way obvious, and you don't need to do any other specific configurations. Again, uh, most cloud infrastructures allow for some type of uh, price discounts for provisioning for longer periods of time, or like the reservation model. Again, something very complicated to understand in general, but in the OVHcloud was very simple for us to understand exactly what we need to do in order to provision our infrastructure for what we are planning to use in the future. And another big plus on the cost side is that there isn't any explicit incoming and outgoing data transfers, except for the load balancer costs. What does this mean is that there is one place only where you have to look at, okay, what are the costs? How much is it? How do I calculate it? It's very simple. In comparison, other companies, other infrastructures have separate cost for bandwidth and separate cost for load balancer, and you have to figure out if it's additive or not, and how do you measure everything. Some costs are related to the SSL offloading, some are not. Pretty complicated. With OVH, we found that, again, in the cost transparency side, very straightforward, very easy to understand. One place to look at and see how much this is going to cost you, easy to predict. Okay, from a user experience perspective, we like a good designed application. We just like that. And the control panel for OVH is very responsive. This means that it's very easy to navigate, go around, see what you're trying to see. Uh, Not very common within the cloud industry. A lot of control panels we've come across very bloated with good reasons, but I think that is very important when you want to deploy your applications, your infrastructure to a provider, to be able to quickly navigate and see what is going on, move from one part of the control panel to another without having to be sure you're clicking the right thing, because otherwise you'll have to wait 5-10 seconds for a page to load before you can do anything else. I mentioned already the great customer support that helped us with a lot of things that we didn't quite get about the infrastructure. The professional services, I mentioned the fact that we like to push boundaries. That's true. So it's common for us to find edge cases in infrastructures. The fact that we were able to work with the professional service team and find a fully implemented solution within 3 days for our problem, it was a great thing for us to happen. And for other things, we were able to directly or almost directly talk with the engineering teams and get feedback on what we were trying to do and what was failing in order to find the best way to deploy to this infrastructure. So I think this kind of sums up my presentation of what our experience is deploying the infrastructure that I mentioned initially, also on on this on the OVHcloud. Thank you very much, Remy. And if there are any questions at the end, like Remy mentioned, thank you.
Yes, thank you for the complete vision about where you started, where you went with your infrastructures, and how we could interact and propose you products that you thrive with. So it was a very interesting feedback and a complete one. I will now give the mic to Robin to take the next slot to talk about migration and how go from private to hybrid with the bond. So, Robin, are you with us?
Yes, thank you
Perfect.
very much, Remy.
The floor is yours. I let you
Thank you,
introduce
Remy.
yourself.
Hi, everyone. My name is Robin Paquet. I am a pre-sales engineer for OVH. I've been in the company for 5 years now, working in more technical and commercial role. And before OVH, I used to work at VMware. So I'm coming from the virtualization layer. For today's topic, we decided to share the story of Boond, which is one of our customers. Boond is a software editor based in France, and we wanted to share their very interesting story from a legacy application based on private cloud to a more hybrid application based on microservices hosted in both public and private cloud. We will come later to the Boond story and migration specifically. Before, we wanted to share what we are talking about at OVH when we say private public cloud, because we call it product universes, which are ways to categorize products. But what it really is, it's a way of consuming and hosting services in the cloud. So if you go into your OVH control panel, basically you will see 3 or 4 ways of consuming cloud. The first one is the one we call bare metal. So bare metal is the historic way of hosting services at OVH. Bare metal is really aimed at companies that are looking for full autonomy. So if you want to manage the virtualization by yourself, if you want to host database by yourself, if you want to host Kubernetes by yourself, bare metal is the way to go. Basically, for OVH, it's quite simple. We deliver you a dedicated server, a naked server with nothing on it, and you do everything else. So it's really aimed at companies with a lot of admin sys within their ranks to host and manage all the services. For companies that are looking for something else, that are looking for OVH to manage the dedicated server, but that also looking for an offer that manage the virtualization layer. At OVH, that's what we call private cloud. So private cloud, mostly it's based on VMware, even though we offer it with Nutanix today. And the responsibility of each is quite straightforward. OVH manages the dedicated server as well as the virtualization layer, mostly based on VMware, and you do everything else. So you create your own VMs, you define your own networks, and you host your whole application in the private cloud. So basically what we do is we deliver you a managed VMware or Nutanix environment. Bare metal and private cloud, what you see is that in both cases, you are hosted in the dedicated server, on a dedicated server, meaning that the hardware won't be shared with other customers. The other way of doing cloud at OVH is what we call public cloud. It comes in 2 forms. You have IaaS, infrastructure as a service, and platform as a service. Both are quite easy to understand. So public cloud, firstly, it's based on shared server. So the hardware is shared, mutualized between different clients. The virtualization layer is no longer based on VMware and Nutanix. We use open source software. In OVH case, we use OpenStack. And then we sell, in the case of public cloud IaaS, we propose VMs, so IaaS services to customers on the same shared hardware. So that's the most common way of thinking of cloud. It's what we call at OVH public cloud. And what's good about public cloud is that, of course, you can find IaaS services, but you can also go for something even more managed that we call PaaS. And with PaaS services, basically, you will be able to find database, AI models, network services, as well as security services. So that means that the virtualization layer is still managed by OVH, still hosted on shared server, but we will propose a managed services on top of the IaaS layer. So that's all the product universes you can find at OVH. In the next slide, if we zoom into each of those universes, well, basically on the left, you have bare metal. So in bare metal, you will find quite obviously bare metal servers. So it's the dedicated servers we were talking just before. If we look at private cloud, so we've said we found mostly VMware, managed VMware environments, and now you have an alternative with Nutanix clusters. And then you have public cloud. So in public cloud, you find a wide variety of services. The IaaS services, so the very basic services, the VMs, the additional storage, also the GPUs that are very requested today. And more interestingly, you will find the PaaS services, so the databases, the containers, and everything related to AI. You can see that in private cloud, we are talking about VMware, we're talking about Nutanix, SAP, so big companies. With public clouds, it's more about open source. We're talking about Kubernetes, about open source database engine, such as PostgreSQL. Same thing with AI. We will offer open source, open weight models. So everything, those three ways of doing cloud will be built on top the same networking layer. At OVH, we call it VRAC, is the private network that you have to host all of the services mentioned just before. This network is very interesting for two reasons. It has unlimited traffic. So we don't charge the traffic between regions, and also inside the same region between AZ. Also, it's the same network in all cloud regions. So if you have to build an application, an architecture between Asia, Europe, and North America, you can have the same private network between all of those regions with unlimited traffic. You have ways to connect your on-premise to OVH with OVHcloud Connect. You have ways to secure the network with anti-DDoS and edge firewall. And also you have transversal services such as IAM, logs data platform to store logs, KMS to store your cryptographic keys. All those security and identity services can be used with all the universe just mentioned before. So that's the products you can find inside each universes. And in the next slide, we will see the two ways you have to deploy those services. Historically at OVH, the cloud region we offer are called one zone. So they are one zone region. It means that inside the cloud region, you have only one availability zone that we call AZ. One AZ is one or more data center in close proximity. So you have one or more data center close to one another. That means that they will share a network peering that is redundant, and they will also share power supply that is redundant. So in the case of the three cloud region, one AZ we have in France, for instance, Roubaix has 9 data centers in proximity to one another. Gravelines has 3 data centers in proximity to one another. Strasbourg has 2 data centers in proximity to one another. But now, since 2 years, we've had a new way of deploying region at OVH. They are called 3-zone or multi-zone region. As of today, we have 2. We have one in Paris and one is Milano in Italy. Those regions have the specificity to contain 3 availability zones within one region, meaning that in the same region, you have data centers that are distant between one another. The distance is between 30 and 50 kilometers, and the latency is 1 millisecond. 30 to 50 kilometers means that if something bad happens to one data center, my other data center, my other AZ are safe. But the latency of 1 millisecond shows that it's close enough to run high availability workload, such as database, such as Proxmox cluster, between 2 or 3 AZ within the same region. So within a 3AZ region, you have the compute services such as VM and the bare metal server that are at the zone level, meaning that you take one in zone A, zone B, zone C. But more interestingly, the storage, network, and managed services are on the region level, meaning that if you take an object storage, if you take a load balancer, if you take a Kubernetes cluster, the service is distributed within the 3AZ, on the 3AZ within the same region, and is tolerant to the fault of one AZ. In the case of Kubernetes cluster, for instance, it's very interesting because your load balancer is regional based on the 3AZ. Your control plane cluster is also regional, so hosted on the 3AZ, and you can deploy pods with replica between different AZ. So it's a great way to deploy high availability application in the cloud. So in the next slide, we will focus now on the story of Boond. Boond is an OVH customer. They are a software editor based in France. We'll talk about the journey they had from an application hosted in private cloud, on private cloud at OVH, to a more hybrid architecture based in both private and public cloud. So Boond is a productivity platform for IT consulting firms. Basically, in the past, IT consulting firms were facing the challenges of having to deal with many different tools that wouldn't talk to one another. So the proposition of Boond is quite straightforward. It's an all-in-one platform, meaning that you can manage CRM, ATS, time management, invoicing, and reporting within the same Boond platform. Also, it natively integrates integration with other tools, meaning that all services accessible in the Boond platform is built with 100% open APIs that you can use quite easily to integrate with other services. So Boond has been quite a success in France because they are now the leader to the leading software for small and mid-sized IT consulting firms. 4 out of 10 IT consulting firms, small and mid-sized, are equipped with Boond in France. That's a total of 2,000 customers today. And interestingly, the Boond customers are outgrowing the market by 2.5 times, showing the real value that Boond is bringing to its customer. So they've created this great success with a private cloud approach. At OVH, a private cloud approach is basically based on 2 cloud regions. So they have 2 very big VMware managed environments, 1 in the main region and 2 in a secondary region. Both environments, so the main one is made today of more than 15 physical servers, and the secondary one is made of more than 10 physical servers, so quite big VMware environment. For both, they use performance hyperconverged storage using the vSAN technology from VMware. And regarding the networking and the security, they use NSX also for VMware. And both environments are built within the same private network that we've seen just before. So all of it is within Boond's own private bubble within OVHcloud. And they've managed to build a very robust and strong architecture because VM are replicated near real time between the 2 environments, so between the 2 regions, with a RTO around 10 minutes to go from one to another and a RPO close to 0. So in terms of what we can propose at OVH for private cloud architecture, it's really the best practices that they've put in place. So Boond managed to grow using this private cloud approach for many years now. And some time ago, they decided to define a new strategy to keep growing. This strategy was based on 3 pillars. The first one is that they want to expand in Europe. Today, they are very big in France, but they want to expand outside of France, specifically in Southern Europe. In terms of architecture application, that means that the deployment that was mostly done with homemade scripts today were to be automated with market standards. Then they want to be able to scale with usage. They want to build natively in their application and specifically in the test environment, some auto-scaling method to adjust the infrastructure to the application needs. And then they want to increase availability, specifically the 3AZ, specifically they want to use the 3AZ model that we've discussed just before in order to deploy application no longer in a DRP, disaster recovery approach, but with a high availability approach. And this is done through regional 3 availability zone Kubernetes cluster. So in the next slide, we can see the journey Boond decided to take. So they've taken their legacy application. They have been very kind to share with us the new design of the application. They've taken the legacy application and they've transformed it into a microservices application. Basically, the legacy was split into 10 different layers that you can see on the screen. So public, entry, application, data and processing. Then you also have observability as well as business intelligence. And then the more infrastructure layer based on CI/CD, access for security, and then backup specifically with Vault. So you have those 10 layers. For each layer, they've decided to choose either a leading technology, for instance, such as Cloudflare, or a leading open source component that they could access easily from the community and deploy as a microservice. You will see, of course, Nginx. You will see for the data layer, MariaDB, Redis, RabbitMQ. For the observability, you will find the classic Prometheus, Grafana, ELK. For the business intelligence, you will find Kafka, Trino, ClickHouse, etc. So Boond has been very kind to share with us the different technologies they choose for their new microservice application. In terms of hosting and infrastructure, they've decided to not go for a full migration in one go, which would have been too complicated. They've decided to go for a very subtle and interesting approach. First of all, in the same private network that we've seen before, with the two regions and the two managed VMware environments, they've decided to add a third region, Paris region in this case, based in the 3AZ. And the Kubernetes cluster is deployed in the same private network as the VMware environment. And the application that was transformed into microservices is now partly hosted into VMs from private cloud, so container on VMs. And for the test environment and certain production environments, they've started to migrate the containers into Kubernetes, managed Kubernetes directly. So as of today, all of the test environments run on managed Kubernetes with the ability to scale the application to the need, with the ability to go from one AZ to another if there is an issue there. The production environment is progressively migrating from the private cloud environments to Kubernetes, to manage Kubernetes service. They've started with the business intelligence and observability layers. And in this case, either they self-host the components in Kubernetes directly, or they go for a managed services. That's the case, for instance, for ClickHouse. They go for a managed services offered by OVHcloud directly in the public cloud. And in this way, as of today, they manage to get the best of both worlds. They keep what has been running for years now in the private cloud with a very robust approach. They migrate what they can gradually to the public cloud for the production environments. They started with observability and business intelligence. And for the test environments, they were the first to migrate to public cloud to really get the best of the auto-scaling capabilities of Kubernetes. That's it for me. That was the story of Boond and how they created this very interesting hybrid architecture between the two universes, private and public.
Thank you for sharing the Boond story and how they went from purely private to hybrid, because I think it's interesting and a lot of people can relate to this kind of scenario. And now to dig deep technologically on how we are able to do this, because at some point we have an hardware layer that we need to take into consideration and know what's going on. We have our next guest, which is Alexander, to talk about the next generation of CPU and how we can work with them and see how they perform right now. So I'll let you introduce yourself, and the floor is yours.
Well, thank you, Remy. Thank you for having me today, and thank you for everyone who stayed over still in the call, in the webinar. I mean, my goal is to pretty much today is to answer one question and one question only, which is how to achieve better scalability and performance and innovate faster at the same time. And I think it was very exciting to see the stories, right? So with Bitdefender and Boond around the different types of deployments and all the complexity and all of the end-to-end solutions which we are able to arrive to with all of the different possibilities and all of the different workloads, software, and so on and so forth. So, and I think it's very exciting. So my goal is to hopefully make hardware also exciting today. So let's move into the next one. And my role as a product marketing manager for AMD EPIC, specifically at AMD. So I'm not here to talk about too much CPUs and data center strategy we have. The answer which I have to the underlying question, which is again, how to achieve better scalability and performance and innovate faster, is pretty simple. It's all around OVHcloud and AMD EPIC. So here's why. Together, we have various sizes of solutions and use cases to satisfy any customer needs across, well, dedicated servers, which were mentioned a number of times, as well as the public cloud. And you heard today about Kubernetes container deployments, you heard about virtualization, you heard about databases, you heard about much more, right? So AI models, more than that. And there are solutions and deployment options available to you now across all of that to satisfy any type of need. And so this slide specifically goes into the simply different types of solutions we have been offering across the portfolio of 2026, for example, and 2024, so 5th and 4th gen bare metal dedicated servers, as well as the public cloud. So you can see how it all matches towards particular workloads and how it all matches towards the technical requirements. If you want to go into the platform level, I would say, definition and platform level configuration. But most importantly, it's just here as a summary to give you once again a proof point, which is we have a solution together. So OVHcloud and AMD. So from our perspective at AMD, so if we go to the next one, our focus is getting the best silicon out there to our partners and customers. Here's what we have delivered over the 5 years, or sorry, over the years and 5 generations with AMD EPIC, so our server CPU lineup. And it's all based on so-called Zen architecture. That's the semiconductor within our product portfolio. That's the term we use for core design. So Zen architecture specifically has 3 key pillars. It's scalability, performance, including performance per core, by the way, and energy efficiency. With that being said, that's exactly the point of this slide. So just show you what we were able to achieve over 7-8 years and 5 generations of products, delivering every time more and more to our customers and partners to use and offer. And as a result, we were able to achieve, well, more than 500 performance world records across different products and generations of those products and different workloads. So, and this is the next one, right? So just a summary of all of the things we were able to do. So on the next slide specifically, with the most exciting part to me being not the number of different performance world records, but the whole range of various workloads. So having the performance leadership in virtualization, HPC, energy efficiency, database, whatever it's structured or database management, business analytics, AI platform text and meta analytics, rendering, and much more. So why is this important? It's so that you know, as the customer and the user, that by choosing AMD EPYC products and the instances or services out there, you're getting the performance leadership to power the workloads innovation you need. Simple as that. So whatever you do, blockchain, database, containers, web hosting, virtualization, VDI, HPC, or any other workload, you can be sure that you are getting the best out there by provisioning AMD-based OVHcloud bare metal servers or cloud instances. So another proof point to give you, just as a closing item, more or less like a cherry on top of the cake, is the next simple performance benchmarking, which you can find all publicly online. So if we go into the next one, and now you see it, this is a Phoronix test suite. So it's a set of, I think, over 140 or 150 different type of workloads. So subsets are here, so you can find it, right? So web serving, email, blockchain, video encoding, Java, what else do they have? Archives, and so on. So there's a bunch of things there. And you can see how we perform simply from AMD's perspective. So pure CPU, right? So what we can deliver on the semiconductor level. And you can see how we compare latest to latest across different workloads. The results you can, again, find all publicly online. And if you're looking for more info and just simply picking the right product out of the OVHcloud stack and the right solution to cover your needs and innovation, just reach out. Reach out to the OVHcloud team, reach out to the AMD teams to find out what will work best for you, for your particular use case, for your particular scenario. And Remy, I'm not sure if I'm taking your reins in here, but I would say we would be more than excited to hear more of those stories, like with Bitdefender or Boond, later on in the webinars or in other occasions. So with that, I'll pass it over back to you, Remy, and let me know what you think about that.
Thank you. Thank you for detailing how the performance evolved through the years, and I think it was quite obvious looking at the charts, seeing that on the 7 years span, the different generation really outperform themselves. I mean, from the previous generation, and it's quite impressive to see it like this, because usually it's only shown versus the generation before. But seeing the timeline like this, I think it's pretty impressive, and we forget sometimes the gains we have every year with the new generations of CPU and with the hardware. So thank you for enlightening us about these points. I'm open if we have one question in the chat. Yeah, if someone has something to add or a specific question to one of our panelists today, feel free. If you're a little bit shy, you can, of course, send us an email or a feedback about the session. We will gladly answer you with more information and with the recording of the webinar. So if there is no question, feel free. No question? Okay. So I hope we were clear on every topics, and it was a pleasure to have today my speakers. I hope everyone learned something, because we thought it could be important to address the scalable cloud topic and see how we can tackle some pain point and show how the cloud can evolve. Thank you for attending. It was a pleasure to be your host today, and thank you for all the colleagues who worked on this webinar and to our panelists today. Thank you very much, and good afternoon, everyone.